Thank you for participating in our ongoing series of educational webinars here at Maser Consulting. My name is Kevin Hanna. I am the Director of Terrestrial LiDAR Services, and I will be speaking to you all today about advances in terrestrial laser scanning. One distinction I want to make here is the use of the word terrestrial. Maybe 15 or 16 years ago, people would wonder what that meant, but now with all the advances in technology, as we'll see here during the course of this presentation or WebEx, we need to distinguish terrestrial laser scanning because there's aerial LiDAR and mobile LiDAR. So for all intents and purposes, terrestrial laser scanning would be tripod mounted or laser scanning where manual involvement, where someone's actually standing or moving with the scanner, describes the process. One note I would make too is as we progress through this WebEx, please, focus on the imagery here. It's very important to emphasize in terms of looking at where we've been and where we are right now, the advancements and changes. It'll be very apparent just by looking at the images themselves about how much progress has been made over a relatively short period of time, and something that involved a lot of people's vision and sacrifice, I might add. A little bit about the agenda. As I said at the start there, I emphasize studying the imagery. Take a look at the image there on the left of an early laser scanner, a Cyrax 2500, which later became Leica. As you can see there, there's a lot of bits and pieces. We've got a large box and a laptop and cables and a power source. And that scanner there was probably over 50 pounds. So right away, you can imagine in the early days how cumbersome it was to move the equipment around. But again, early innovators had a vision, and that was to capture reality. So we'll see that as we go through this WebEx, just how far we've come with that. So to the agenda, we'll do laser scanning, a brief history, so we can put it all in context again, so we can kind of appreciate where we are right now, right up to the minute. The laser scanning workflow, that's a traditional workflow, recent advances in technology, and the capabilities and applications that it's opened up to us as laser scanner practitioners. Now, one note I'd like to add is that I'm sure there's people attending, listening in, who are serious laser scanner practitioners, surveyors, measurement scientists, architects. Again, there are different laser scanners for different applications. We certainly recognize that. Okay. So as I said, we'll go back to the images there. You can take a look there up on the left to the early Cyrax system. I think that weighed about 70 pounds there, sitting in a tripod, not easy to move around. We have a Regal system there with a laptop and the Cyrax system. And then in the bottom there, an early Leica scan station, more accessories. So laser scanning has been around since the 1960s. Early laser scanners took hours to complete scans. Equipment was very cumbersome. I mentioned weight, and scans were very inaccurate. And to be honest, the computer requirements was years behind. So to process the data or the LiDAR that was being gathered by these laser scanning devices, there was quite a substantial amount of number crunching, which lent a very long processing time. And in some ways, it hurt the technology. But again, the vision of all the earlier practitioners and manufacturers was to capture reality. That's what we're trying to do here. And I think in a short period of time, it's been very, very successful. So 1992, Mency, who later became Trimble, had a scanner that could capture 100 points per second. Now, just to elaborate on the points per second, we all know from looking at our smartphones and even our Blackberries back in the day that everybody wanted a nice picture. So it was very pixelated. The picture would look coarse. And nowadays, of course, we have beautiful imagery on our phones. it's all accepted. That was a challenge in the early days with laser scanners because the scans themselves, the point clouds, were like 3D photographs, and they were very pixelated or coarse, which had a direct effect on the accuracies of the images or scans themselves. So that, coupled with the field of view challenges, meant that there were more scans to complete an area, longer scan times. So there were limiting factors in the early days. And that started, like I said, in 1992, right up to 2006, where the scans or the 3D pictures became much, much better, much, much crisper. And then the field of view became what we know as full dome. They were 360. We all know what 360 is. We can see everything around us horizontally and vertically. Now, this next slide, again, to go back to the images, you can see that the equipment is more compact. Gone are the batteries and cables on laptops. And it would be remiss of me if I didn't say that they were much easier to use. Intuitive, I'd say, in some respects, particularly with our younger generation who have grown up with smartphones. It was press and go, so to speak. And the other thing, too, is it's all about supply and demand. And certainly the equipment that's available today satisfies that requirement. So the equipment's, just to recap, is it's lighter, it's easier to use, the scan data is better, it's more accurate, and also the scan times themselves are extremely short. When you consider in the early days, a typical scan may take 40 to 45 minutes. Now with current equipment and software, a scan can be completed with imagery in under a minute. Okay, so to put things in context, it's important to describe traditional laser scanning workflow. So on the left here, I'm sure you can't read all the numbers and people probably don't care to look at all the numbers, but there's a lot of number crunching, there's a lot of processing, and even in the field, we have to scan and we also have to target our scans so that we can, quote unquote, stitch all the scans together in one big point cloud. That image there in the bottom is a target. What we're trying to do is move away for this particular type of laser scanning, which is a focus on large interior spaces. So again, just to go over the workflow, you have project planning, and that always makes sense to look if you have any legacy data, how many scans particularly you may need, where you're going to place the scanner. Is there different floors? Do you need to run surveying control through the stairwells? Because the goal is to capture reality so that you can see all the floors on top of each other in their correct position. Then to the scanning itself, downloading the data, registration, which is the process of putting all the scans together, which is that slide up there in the top left, where you've all the quote unquote number crunching, and then the delivery, whether it's a point cloud or a model or imagery, which is being sought out by users more and more. Okay, so we'll take a point to recap here. Early equipment was heavy. You had a limited field of view. You didn't have the quote unquote 360 bubble view, if you like. Power supplies was a challenge. Batteries didn't last that long. They usually added extra weight and limited mobility. Scan times were very, very long. The point cloud, or the data that you were gathering, the LiDAR, didn't have the required accuracy. Accuracy now of 1/8 of an inch or better are obtainable with laser scanning under certain conditions. Image quality was poor. Early laser scanners didn't have image quality, but as the years went on, there was the ability to capture RGB data, spherical photographs, 3D photographs. That was a challenge also. And then the processing time was rather long. To sum it all up, it was prohibitively expensive. It took a long time, but for the people that were involved, the scientists, and then the earlier practitioners, everybody had a vision, and that was to capture reality. So we had to go through this process, and it's important. They say, you know, if you want to know your future, you have to look at your past. That's why this slide is here. So we have an appreciation, and we can put things in context of where we are today with laser scanning, or reality capture, as I keep saying. Okay, we're jumping forward to the future. Again, if you look at the images there, notice that the scanners themselves have gotten a lot smaller, so they're more portable. I will tell you too, as a practitioner, you can put them into tighter spaces. Can you imagine some of those earlier images we see there, trying to put them into small confined spaces or tanks or stairwells? The devices that we see here now can be turned upside down, quite honestly, and operated from a remote distance, which has a huge safety component here. They can be run with an iPad, a tablet, or even your phone. So more pointedly there, to look at some of the improvements. Current laser scanning equipments, they're more mobile because of their weight. Some scanners are 10 pounds and less. We see the BLK 360, the Trimble, the RTC 360. There's a number of manufacturers out there. Indeed, the playing field has been leveled because most equipment manufacturers offer laser scanners now on the market. It's not just one manufacturer. Ease of use, reduced operator time. As I mentioned earlier, it's point and press, which is what people want, supply and demand. The equipment itself is much, much easier to use, which is a huge benefit too. Scan times are down. Early days, I mentioned again, scan times could be 40 minutes or more. Now you can do a scan with imagery in less than a minute, in some cases 30 seconds. The coverage is easier. You can gather a lot of data. All scanners are 360, 270, as we say a lot, or full dome scanning for scanning practitioners. Now, here's an important one, auto registration. I showed you an image there of all those numbers. For some deliverables now, we can scan, get the coverage we need, and as we're scanning, all of the scans have been tied or stitched together. That's called auto registration, which was a huge advancement in the technology and software. Some of the scanners now also have GPS capabilities, or L1 GPS, which aids with the registration process. One other feature which I personally was blown away by is we have live scanner tracking. So imagine scanning an interior space, looking at the scans progress on your tablet, your iPad, what have you, or your phone, and you can actually see yourself move around in the space that you're scanning, at the same time watching the scan coverage grow. So, which is very, very useful. It's also got a very positive QA, QC measure in that in the past, when scanning was being completed, you were relying on someone's 3D awareness of sensibility of where they were so they could get all the coverage. Frequently, you didn't know you'd got the coverage till you'd gone through the whole processing and registration to see, well, have we covered the entire floor? Are there any void areas here? Now, with current advancements, we can watch the scan or the point cloud or the progress of the reality capture grow before us on the screen. So you go out there, do your scan, you know you've got everything, it's registered, and you're done, which also helps the end user, and it reduces the project time cycle. In other words, you can gather the data and deliver it in a lot quicker time than you did some years ago. The other thing too, which is important to mention, is imagery has increased incredibly. There's a possibility now with some scanners to provide HDR, or high dynamic range imagery, because there's multiple cameras on board the scanners. This is particularly important with heritage work, or for example, if people want to see numbers or information, textual numbers or labeling in the scans. High resolution imagery is very, very important. Again, supply and demand. People want to see the imagery. And one thing I notice is that while at the background, at the root of all this is laser scanning, people want to see the imagery. The scan data or the point cloud is there to provide the ability to take measurements. Also, GIS capabilities. Now we're using tablets. So I've talked about how the tablets can help us keep an eye on our QA, QC, monitor the coverage, but also there's the GIS needs that people may have. You can take photographs, record small movie clips or audio, comments or notes that may be important that go along with the actual scan data itself. So when the data is quote unquote downloaded, all that metadata or information about information is in the scan itself. So it really is, it's now becoming a measurement, visual, and audio database. Again, it's reality capture. That's the goal. And also the equipment has become more affordable. I mentioned earlier that it was very expensive in the early days. It was cost prohibitive. Now the equipment has become more affordable also. Okay, so here's some more images to just to recap on the advances of laser scanning. You can see up there in the top there, image quality is much, much better. This image here in the middle here shows a scan progressing and one scanner that's been used. And then at the bottom, on your smartphone, you have the ability now that once something is scanned, you can provide a link to an end user, or a real estate owner, a commercial developer, so they can actually see the results, the imagery, with the scan data in the background on their phone, which is tremendously convenient and very cost efficient and a very, very powerful visual tool. So far, we've talked about terrestrial laser scanning. I made a note at the start about distinguishing it from mobile LiDAR and aerial. Well, it's here, folks, as they say. We have indoor mobile LiDAR. And the image here on the left is the Navis M6 system. Essentially, now we can drive through a space indoors, gather the data, gather imagery, and register it as we walk along through a space. So you don't need to know that much about laser scanning to know that this is an excellent solution to gather information rapidly, and also provide various end products to users that people are all used to having right now. In other words, they can see it on their phone. So a little bit about the indoor mobile LiDAR system itself. There's now 4 scanners on board, and the reason we can do that is because they're smaller, they're more compact. We have 6 cameras on board, and the data itself, the scan data, is ubiquitous. Most softwares, to be technically here for a second, all accept scan data in some form or others. A number of the scan formats are open source, they're readily available. What would be the point in having a wonderful system if only certain people that had certain softwares could use it? Everybody can use this data. The other thing too, I guess the most important thing is just how quickly we can gather this data. So you can see there, we can scan about 150,000 square feet in a day in a typical office space. To do that with laser scanning, it's like a factor of 30. It wouldn't be worth even trying to do that. So we can cover a large amount of data or ground in a very, very short period of time. Okay, so here's a sample of a scan from an indoor mobile LiDAR system. I hope it's not too pixelated. It is an image there but you can see all the beautiful colors and all the detail. Imagine having that on your phone. Imagine there was a large piece of real estate or commercial real estate that your company had owned and you couldn't get to. How great would it be to have all that on your phone? And that's what we're talking about here. So this is called a dollhouse view. And as we'll see in a moment here, you now have the ability to immerse yourself in that space without actually having been there. Okay, so just a little note before I go into our demonstration here. We will be in the future doing a full-blown WebEx on indoor mobile LiDAR and the viewer and all the rest. There's been quite a bit of interest about this already. So today would be the quote-unquote teaser, I suppose. Okay, so here we are in the indoor viewer. So I'm sure some of you listening in are used to the bubble views or 3D views. So we're in the space itself. I'm zooming around here. You can see the imagery is really, really good. Now again, the capabilities are available for people to have this on their phones. Overhead, there's no limitations with the field of view, which I mentioned early on in the presentation. Now I'm going to stop for a second. If you can see in the lower right-hand corner, there's actually a small dot there. That's where we're located currently. So what I'm going to do is I'm going to immerse myself in the imagery, practice what I preach here. So you can see yourself move in the plan view. So we're driving our way through the reality capture of the scan itself. And this is a scan. This is a scan. Everything that you see in this view is measurable. There's point cloud data in the background, if you like. So the imagery has intelligence. So I'll demonstrate that here for us in a second. Let's move our way through a little bit more. Okay. Zoom out a little bit. And to use the viewer itself is very, very intuitive. Anybody that uses a computer, which is everybody that can use a mouse and point and click within like 10 minutes, would be very comfortable using the viewer itself. So let's do a measurement. Okay, so what we're looking for here is a vertical distance. So I'm going to pick a view here, the underside of the door. There's the dimension. One thing to notice there is I know many of you would like to see feet and maybe architectural units. For this purpose here, a demonstration, everything is in the European units in meters. So the important thing to point out here is that with earlier viewers that had metrics or measurement capabilities, the dimensioning wasn't intelligent. In this case, with the viewer, the vertical clearance is intelligent. It's from the underside of that door normal, or it's the nominal dimension to the floor distance itself. So again, a very powerful tool. We'll go back now to our viewer a little bit more. You can see over here on the left what corner of the building we're at. So that will help you navigate. In a way, it's like indoor GPS as well. It's real time. It's a very, very useful tool. So you can imagine for somebody maybe that was thinking of purchasing a large warehouse or a multi-level building, and they wanted to repurpose it or maybe move equipment or move walls or take some dimensions or elevations. All of this is now available with this reality capture and immersive photography right at one's fingertips. And also the information can be provided in a very, very short period of time. So it's like Google Earth, but it's indoors. Zooming around again. Let's do another dimension. So you get the idea of just how useful and intuitive and powerful this indoor mobile LiDAR and reality capture is. Okay, so this indoor mobile LiDAR system we have so far, maybe some of you have realized this already, is limited by the fact that you're rolling on wheels. So you have, if you have tight spaces or going upstairs, it can be done. I know people that use this equipment, but the manufacturer has come up with a system called a VLX, which is a mobile unit that sits on top of a person. So you can see here, this young gentleman here has the scanner on his shoulder. All the information, the LiDAR complements the data being gathered by the M6 system. There's 2 onboard laser scanners and 4 high resolution cameras. So this device, quote unquote, would fill in the gaps where the M6 of the mobile unit just basically couldn't get into those corners. It's worth mentioning too that all of this information that we're gathering, the point cloud data and the imagery, can be paired with more conventional static scanning, as we mentioned earlier on in the presentation. It's all ubiquitous. It's all scan data. The manufacturers realize this now. But this device here means that your coverage can be more complete. It's a wearable device that positions the hardware on the front for greater control and higher quality data. So all we're saying there is when the project is completed, if it's done the right way and we use the equipment properly and put it all together, there should be no void areas or shadows in the final product. And again, you're moving a lot quicker as well. It's how fast you can walk with the scanner. Okay, so a little recap here. You recall earlier on, we were talking about maybe some of the detractors or things that helped us back earlier on with early days in scanner. The equipment mobility, it's lighter, it's easier to move around. I mentioned you can turn it upside down, you can put it into confined spaces. Imagine using a device like that to drop it into a large chamber or manhole so you're not compromising someone's safety or having to bring confined space protocols into play. Scan coverage is more complete. Now it really is panoramic, 360. Batteries are really not an issue anymore. They're quote unquote hot swappable. So there's no reason for you to stop work as you change a battery or if a battery dies. The important stuff too is the scan durations can be less than a minute. As we saw with our mobile mapping system there, the scan durations are continuous. It's as long as you can keep rolling with the device in a given interior space. The quality has got a lot better in that there's low noise. So the scan data is more crisp. I think it's important to say that. And that has a direct effect on accuracy. And again, of course, the image quality is vastly improved. So the cameras on board are true cameras with crisper imagery, high pixel resolutions, high dynamic ranging, and makes it more pleasing to the eye and makes the reality more real. And then, of course, the processing time for this type of work is drastically reduced. So I've talked about it a few times. I'll mention it again. We're now in the world of reality capture and 3D immersive imagery. You can immerse yourself in the reality on your laptop or your phone. So we're almost at the end, everybody here. Just worth pointing out here that the 2 images we see to the left, at first look, that looks like a photograph. It is not a photograph. This is an actual scan that's been modeled and lighting at it and all the rest. Plus, there was a tremendous amount of detail gathered with the scanner itself. So it shows the power of laser scanning and how far we've come. And then, of course, below is a transparent view, or typical Revit model that was used for redesign and repurposing of a large warehouse. So, main points. Current advancements in 3D reality capture and immersive imagery can be applied to a wide range of applications. Large commercial and industrial properties of 1 million square foot or even more are no longer a challenge. Convention building documentation such as CAD drawings and BIM and Revit models is a standard delivery. 3D immersive imagery, I've talked to that all the way through this presentation. GIS applications, asset management, data about data. The uses, interior space analysis for building repurposing. Standard deliverers like AutoCAD, Revit models are all provided with the current technology, or I should say, provided in a more time efficient manner. And the current trends to seamlessly fit the existing workflows of third-party solutions. So what we're saying there is that all of this technology is designed to work with other softwares, because it's a very competitive field, but all of this is interchangeable. It's interchangeable, which means more people can actually use it. So that's about it. I know we just touched on topics here. As I said, we will have another WebEx focusing more solely on indoor mobile LiDAR. Look forward to that coming up. So we have a question and answer session. Maria, back over to you.
Okay, great. Thank you so much for the information, Kevin. We have a couple questions. This question is from Dan. I have a warehouse to scan. It's about 250,000 square feet. How many days to scan with the Navis system?
That'd be about a day. I wouldn't have said that to you 10 years ago. That would be about a day.
Okay. Another question here is from Jack. Can you combine static scanning with the Navis system?
Absolutely. That was one of the last points I've made. It's all interchangeable. You absolutely can make hybrid point clouds where you have indoor mobile LiDAR and take scan data from a Faro scanner or a Trimble scanner, or a ZNF scanner, and actually merge that into the overall point cloud gathered with the mobile LiDAR.
Great, thank you. And a question here, this question is from Gina. What is the relative accuracy with the Navis system?
The accuracy question. Well, so I'll answer that question two ways. You have controlled and uncontrolled scans. So for non-surveyors on the on listening in, where we have survey control, in other words, we locate and derive coordinates for targets in the Navis scans, the accuracy there would be plus or minus a centimeter under normal conditions or ideal conditions. But for uncontrolled, it would be about 2 centimeters.
Okay. That actually looks like that's it for the questions, Kevin. Do you have any, I guess, final last remarks, comments before we end the presentation?
No, I think that's about it. For anybody that wants to go to our website, there's a link there on the slide. You want to watch it again or look at slides or pass it along to people, we absolutely encourage that. And indeed, if you have any other questions and want to dive into the accuracies or potential projects or opportunities, please feel free to follow the link there provided in our last slide. So thank you all very much, and I hope you all have a wonderful holiday weekend.